Hi, and welcome to another episode of Technical Quick Tips from Directed Energy. I'm Bob Schmid from the Applications Engineering Department. We're going to talk about the difference between gate and trigger today. Our products are sometimes outfitted with one or the other, and the question is, what do they do? When we have a gate input on a pulsar, either a voltage pulsar or a current pulsar, it usually means that the output follows the input. If that's what's happening at the input, we can expect the output to do the same thing. So the gate really sets the width of the pulse and it sets its frequency. The more often the gate pulses occur, the faster the output pulses will occur as well, so we have a one-to-one ratio on that. A trigger is a little different. If we generate a trigger pulse and feed it to either a voltage pulsar or a current pulsar, the output is typically self-completing. In other words, the output may be a pulse that's very narrow, and the width is set by the hardware or perhaps programming. The trigger's leading edge simply goes ahead and starts the pulse going, and its duration is not controlled by the input, but rather by the programming or perhaps the hardware in the case of some of our products. So that's the difference. We tend to use these terms interchangeably, but there is technically a slight difference. The other thing I wanted to talk about today is that both of these devices or inputs are typically 50 ohms in our products. What does that mean? It means the input to the product looks like it has 50 ohms of resistance across its input, and it means that we should drive this with logic that has the ability to drive 50 ohms. In other words, the function generator or arbitrary waveform generator or whatever it is that we're using to drive the pulse generator has to be capable of driving 50 ohms, which means it needs to be capable of outsourcing 100 milliamps. If we want this gate or trigger pulse to reach 4 to 5 volts, and it's going to be driving a 50 ohm input, it needs to be capable of nearly 100 milliamps. That's not a problem if you have a professional pulsar like a Agilent, Tektronix, HP, Siglent. One of those brands are probably very capable of sourcing the 100 milliamps. But you may be building a product in which you have your own logic driving the trigger or the gate, or maybe this is a microprocessor driving the inputs. Those devices typically don't have enough output capability to drive 50 ohms, so we want to make sure that we follow that suggestion. And that's what I have.